Good afternoon to all my YouTube viewers. Myself J. Das. In this video, I like to discuss about polarization of light. There will be some theoretical input and then we will solve few problems related to this chapter. Now, the purpose of this video is to enhance the performance of the students as they are facing a tremendous competition because of their own batch students, because of the 1 year senior students as well as 2 years senior students are also there. So, under this pressure student has to pass through this. Now, this huge competition can be tackled by improving our own performance. We need not to compete with so many lakhs of students. Our position has to bring in such a manner so that we will be competing only 50 to 60,000 students. That is the objective of this platform. This channel will provide you all kinds of possible supports so that you can boost up your position. Let us come to the subject. The phenomenon of limiting the vibration of electric field vector in one direction in a plane perpendicular to the direction of propagation of light wave is called polarization of light. What is polarization? That is this one. Now come to polarizer. These are thin film of ultra microscopic crystals of quinine iodosulfate with their optic axis parallel to each other, and it is used to produce the plane polarized light. Then we have to understand polarizer and analyzer. Unpolarized light falls on the Polaroid is called polarizer. Once it is polarized light, then polarized light falls on the Polaroid is called analyzer. Now come to use of Polaroids. It has a extensive use in modern science, especially sunglass, in laboratory purposes, in automobile industries and 3D motion pictures. Now, in this chapter, the most important law is Malus law. The law states that the intensity of the Polaroid light transmitted through the analyzer varies as the square of the cosine of the angle between the plane of transmission of the analyzer and the plane of the polarizer. A diagram has been given here. You can see that polarizer is that is placed that optic axis is along y axis and x axis is just perpendicular to that, and you can see that optic axis is showing that is along y axis. Now, once unpolarized light passes through this Polaroid, its intensity will become half of that. Thereafter, the analyzer, which is just after that the Polaroid placed, that is called analyzer. That analyzer is placed, you can see that axis which is shown with some angle with respect to the plane yz, you can say yz, or the Polaroid axis with respect to that, this angle is theta. Now, the plane transmission of the analyzer and the plane of the polarizer, we can understand the angle, that angle is theta. Now, if I naught be the intensity of the polarized light incident on analyzer and theta be the angle between the transmission axis of the polarizer and the analyzer, the intensity of light transmitted through the analyzer is given by I equal to I naught cos square theta. That is very, very important formula. We have to understand what is this formula, and we must go through this one seriously, otherwise this chapter will create problems to us. Let us come to problems. Problem number 1, two Polaroids are oriented with their planes perpendicular to incident light and transmission axis making an angle of 30 degree with each other. What fraction of incident unpolarized light is transmitted? A diagram is shown here. Light is going, you can see that big black dots are given and perpendicular rays are shown, that means into the board and perpendicular to that plane, that means E vector acts in all directions. Now, cos component and sin component are very specifically divided, and one of the component which is parallel to the axis of the Polaroid. Now, light will be polarized, thereafter it will that analyzer has 30 degree with this direction. So, emergent ray will come out accordingly. Now, solution: let unpolarized light intensity I dash. Intensity of polarized light will be I dash by 2. Intensity of emergent ray which is coming out from analyzer, that will be I equal to I dash by 2 cos square theta. Here theta is 30 degree. So, I dash by 2 cos 30 means root 3 by 2. Simplifying this, we can see that I by I dash will be 3 by 8, that is 37.5%. The transmitted light will be only 37.5%. Now, question number 2. A Polaroid is placed at 45 degree to an incoming light of intensity I naught. Now, the intensity of light passing through Polaroid after polarization would be, there are 4 choices. We know I equal to I naught cos square 45 degrees. So, I naught by 2 will be the answer, B is the choice. Now, come to question number 3. Unpolarized light of intensity 32 watt per meter square passes through 3 polarizers such that transmission axis of the first and second polarizer makes an angle 30 degree with each other, and the transmission axis of the last polarizer is crossed with that of the first, that means with respect to first it is 90 degree. The intensity of final emerging light will be, there are 4 choices. A simple job, angle between P1 and P2 is 30 degree, and between P2 and P3 of course it will be 90 minus 30 degree, that is 60 degree. Unpolarized light of intensity is 30 watt per meter square. So, polarized light intensity will be half of that, that is 16 watt per meter square. According to Malus law, intensity after P is I2 equal to I1 cos square 30 degree, which is coming 12 watt per meter square. Then after P3 sorry, it will be 12 into cos square 60 degree. Already have shown that how that angle has come. Now 3 watt per meter square, then answer will be C, choice will be C. Next come to question number 4. Yellow light slit width A equal to 0.6 millimeter, yellow is replaced by X-ray, what diffraction pattern will be seen? There are 4 choices. No diffraction will be seen, it is in the earlier question also we have discussed, because wavelength for X-ray is varies between 1 angstrom to 100 angstrom only. Minimum requirement for fringes that should be that is above 400 angstrom, which is not here. So, no fringes will be the answer. Next question, question number 5. Two polarites A and B are kept in crossed position. We can understand the meaning 90 degree. How should a third polarite C be placed between them so that the intensity of polarite light transmitted by polarite B reduces to 1/8 of the intensity of unpolarized light incident on A? This is a very good question. Let theta be the angle between the pass axis, that is A and C, that is considered. Now, intensity of light passing through A will be half of that, that is known to us, that is I naught over 2. Then it will pass through C, definitely I naught by 2 cos square theta, and then finally through B, it will be I naught by 2 cos square theta into cos square 90 minus theta, yes, 90 minus theta. That will give the expression like this: I dash equal to I naught within bracket sin theta cos theta whole square, simplifying this, and according to question substituting the final value transmitted light, that is I naught by 8, we can get theta equal to 45 degree. Come to question number 6. If I naught is the intensity of principal maximum in the single slit diffraction pattern, then what will be its intensity when the slit width is double? That when slit width double, we know angular width will be half, that is lambda by 2a. Therefore, the intensity will be 4 times the intensity initial intensity of I naught, because as slit with increase double, so amplitude square, we know that intensity is directly proportional to amplitude square, it will be 4 times. Next question, question number 7. Now, when an unpolarized light of intensity I naught incident on polarizing sheet, the intensity of light which does not get transmitted, we have to understand this question. Question is little language, we have to understand, that is the point. Now, here answer will be C, I naught by 2. Let us see. Unpolarized light incident given, that is I naught. After passing through the polarity, definitely its intensity will remain I naught minus I naught by 2, which is I naught by 2. So, intensity of the polarized light, this is polarized light, which is not getting transmitted, that is due to some other reason, that is not mentioned in the question paper. So, answer will be I naught by 2. Now, question number 8. The transverse nature of light is shown by a interference, refraction of light, polarization of light, dispersion of light. Answer will be C. Transverse nature, you know that polarization is there. Next question, question number 9. In the propagation of electromagnetic wave, the angle between the direction of propagation and plane of polarization is 0 degree. 0 degree. A will be the answer. Next question. 10. If a wave can polarize, it must be an electromagnetic wave, longitudinal wave, sound waves, transverse wave. Definitely a transverse wave. That is the basic requirement. That is question number 11. Polaroid sheets are often used for making sunglasses. This is because sunglasses, number A, cut off glare, number 2, are lightweight, and number C, absorb more light than colors glasses, absorb more light than colored glasses. Number D, remove the polarization of direct sunlight. So, out of these 4 choices, A will be the answer, because nowadays modern technology has given lot of advantage on Polaroid sunglass, that they design in such a manner that people due to sun ray, whatever glare takes place on their faces or feelings, or they feel uneasy, that things highly cut off through these sunglasses. Thank you very much. Thank you for good listening. Again, I am requesting that you share through this channel to other people, so that they also can come to know about this. And if you find anything good here, you can like and you can subscribe. Thank you very much. Thank you.